All right, hello everybody, Miss Suchi here. We are going to be doing geometry notes, lesson 1.6. Our objectives today are to be able to, let me grab a pen. To define, classify, and identify quadrilaterals. So remember, quadrilaterals are the four-sided figures. The typical one that you think of would be a square or a rectangle. But there are quite a few, and we're going to put in all of the markings and definitions for them. Now remember, we cannot assume something is a shape based on how it looks. We need to have evidence. So our first quadrilateral that we're going to look at here is trapezoid. And a trapezoid has exactly one pair of parallel sides. Sorry, that's a 1. So it can actually look a variety of ways. The typical one that you see is where the top is is shorter than the bottom, and then you have the two slanted sides. Now, in order to emphasize that the top and bottom are parallel, you have to have those arrows showing that they're going in the same direction. Okay, now that's not the only way a trapezoid could look. As long as you have exactly one pair of parallel sides, it is considered a trapezoid. So here I've made it more of a right trapezoid where the non-parallel side is looking like it's perpendicular. But again, we do have to have the markings showing that those sides are parallel. You cannot have two pairs of parallel sides. That would be a different quadrilateral. Okay, now for an isosceles trapezoid, we still have exactly one pair of parallel sides. So it's still a trapezoid. But if we think about an isosceles triangle has those two congruent sides. So the sides that are not parallel on this are going to be equal or congruent in length. Oh dear. Hang tight. So sorry about that. Okay, so let me restart here. Isosceles trapezoid, those sides that are not parallel are going to be the same length. So basically, I'm going to draw that same trapezoid figure. Showing that the one pair of parallel sides is there. And then the non-parallel sides, so the two slanted sides, have to be the same length. So those are going to be hash marks showing that each of those sides are equal in length. All right, the next one is a kite, and think of the typical kite, old school type of kite that you would fly in the air. So this is what it looks like. Now, you might have been taught that this is a diamond shape, and there are no diamond shapes in geometry. That is a gemstone. So when we're looking at a kite, we typically have two shorter sides and then two longer sides. And the two shorter sides touch at the top of the kite, and then the two longer sides would be like the bottom of the kite. And those sides that are the same length are actually touching or next to each other. So they are consecutive. So this is a quadrilateral with two distinct pairs of consecutive congruent sides. So the top two sides that are the shorter sides, we'll say, those ones are the same length, and I'll put the same marks in those two. And then the bottom two sides that are longer are the same length, but they are different than the shorter two sides. So I put a different amount of hash marks here. And if it helps you visualize it, you can certainly draw in, a little kite tail flying there. All right, that is a kite. Parallelogram. So a parallelogram, well, we could say that a rectangle is a parallelogram. And it's where you have the top and bottom going in the same direction and the two sides going in the same direction. So here we have two pairs of parallel sides. But even though a rectangle is a parallelogram, it does not have to have 90-degree corners to be a parallelogram. So typically you see them slanted, but they don't have to be slanted. Okay, now I'm going to make the top and bottom parallel, kind of like I did that trapezoid. But then the sides, remember, they have to be parallel to each other, different from the top and bottom. So maybe I'll put one arrow on the sides here. All right, next one, rhombus. And this is also a quadrilateral, but it is an equilateral quadrilateral because all of the sides are the same length. It's got two pairs of parallel sides. So it's the same as the parallelogram, but all the sides are congruent in length. So we're still going to have that parallel markings the same as we did for the parallelogram. And again, I'm going to draw it slanty, but it doesn't have to be slanty because a square is technically a rhombus as well. And then I'm going to put in the arrows showing the top and bottom are parallel. A different set of arrows showing that the sides are parallel. And now I need marks showing that all four sides are equal in length. So maybe I'll do a single hash mark in each of the sides. So this is, the blue part here is showing that the sides are congruent in length. And then the red and the green are showing that those opposite sides are parallel. All right, rectangle. A rectangle is a parallelogram, but it is a parallelogram that is standing upright. It's not slanty at all. And that's because all of the corners are 90 degrees. So that means all of the angles are equal, or this is an equiangular parallelogram, a quadrilateral with two pairs of parallel sides, and all the angles are 90 degrees. So I'm going to draw a parallelogram again, but this time not slanted. And even though my sketch does not look perfect, as long as we're looking at the markings, that is all that matters. So I'm going to say the top and bottom have the same arrow sets. And I'll make the sides have the same arrow sets that are different from the top and bottom. And then I'm going to put in those 90-degree corners. Okay, now there is another property on the rectangle that you probably are saying, hey, we need to put this in, and that's that the opposite sides are the same length. And that is only because of these 90-degree corners and parallel sides. So since these sides are going in the same direction and the top and bottom are going horizontal in this case and the sides are vertical, creating that 90-degree connection everywhere, there's only a certain amount of space that the top and bottom can fit in. And so that automatically makes them congruent in length. So maybe I'll put 2 hash marks here for the top and bottom. And then I'll put a single hash mark on the side showing that those are the same length as well. All right, square. A square is a rectangle that has all equal side lengths. It is also a rhombus with all equal angles. It is also a quadrilateral that has all sides the same and all angles the same. So there's lots of different ways that we can write out what a square is. So a square is a 4-sided figure, quadrilateral, with all congruent sides and all congruent angles. Okay, now again, my picture's not perfect, but as long as I have the markings to back up my information, that's all that matters. So 4 equal sides. And 4 equal angles. But because it's a square, those equal angles are 90 degrees. Okay, now technically, since this is a rectangle and a rhombus, we could also put in that the opposite sides are parallel. Because that is a true property as well. Okay, now if I wanted to compare them all together to see which ones could be named different things, we can use this diagram here. So this blue outer quadrilateral here contains all of the four-sided figures, all of the quadrilaterals. So since kite is within this blue rectangle, it is considered a quadrilateral. Since the square is inside the blue rectangle, it's considered a quadrilateral. Outside of here, I might draw something like a pentagon, because a pentagon does not have four sides, so it can't be inside this figure. If we look deeper here, we can see that the square and the rectangle are held within this parallelogram. There is also one other shape that's held within this parallelogram, the rhombus. So the rectangle, the square, and the rhombus are all considered parallelograms. So this is a good reference to say what shape has more than one name that can be associated with it. So we're going to use the image and answer the following questions. Is a rectangle a square? So if I look up here, okay, well, rectangle's right here, and rectangle is inside of the parallelogram. It's also inside of the quadrilateral. So no, a rectangle is not necessarily a square. Oh, that's a terrible N. But when I reverse it, when I say, is a square a rectangle, the square is within that rectangle figure. And that's because a square has all the properties of a rectangle. It has the opposite sides parallel, and it's got 4 90-degree angles. So in this case, the answer is yes. And I got a delay on my computer here. Whoa, there we go, we caught up. Okay, letter C, is a square a rhombus? So even though this is our square here, I have another one right here. And that square is within the rhombus, which means yes, that square holds all of the properties of a rhombus. Okay, why don't you try and figure out the rest of them, and then I will put up the answers as we go here. All right, so that's a great picture to reference if you're trying to figure out which shapes have the same properties. All right, over on the right of our notes, we do have some practice naming these specific triangles based on their markings. So looking at this first triangle, I can see I've got 2 hash marks, 2 hash marks, 2 hash marks, which means 3 equal sides. And anytime you have all of the sides the same, this is equilateral. The picture on the right is another triangle, so I could automatically write triangle. But this one, I noticed that the hash marks are all different. And when they're all different, that's called a scalene triangle. However, that's not the total name. There's one other marking here. And this marking shows a 90-degree angle, which means that this is also a right triangle. So we could say a right scalene triangle or a scalene right triangle. Now maybe you're thinking, well, over here, there was no markings, but those look like acute angles. We could say that this is an acute equilateral triangle. And later on, when we learn more about equilateral triangles, we will see that that is always the case. But typically, if we're going to name acute or obtuse, they should have some sort of measurement in there to emphasize what it is. All right, down here, lower left, this one has one angle that's larger than 90, and it is a triangle. So this would be an obtuse triangle. Now, even though we didn't discuss this, anytime your angles are all different sizes, it means that those opposite sides from those angles are going to have different lengths. So across from this 100 here, this is going to be a different length than the side across from 35, which is different than the side across from 45. And so technically, because of all of the different angle measurements, this is also scalene. All right, the last one here. This one has two angles that are the same size, two sides that are the same length, and all three angles are less than 90 degrees. So noticing the same side length here, this is an isosceles triangle. Because all of the angles are less than 90, we could call this an acute isosceles triangle. All right, on the back is our summary. Now, we're going to cover this tomorrow, but remember, it's not based on looks, because all of those look like squares to me. It's going to be based on the markings. So tomorrow we will refresh our mind at what markings determine what quadrilateral we have.